We look at HTML, and we started doing it last week. We'll look more at HTML today. Once we got a better idea of what HTML does, we'll look at PHP, which is basically fixing a programming language into the HTML code to make the web pages do stuff that they can't do otherwise. Then we'll mix our database in as well. And once we got all of that working, we can start installing our first content management system, which is going to use all of those technologies to make your website work. Reading lists, they are all online. If you want to buy a book, that's probably the best book to buy. And yeah, last time we talked about the internet. And I think last time we stopped at domain name, at the domain name system servers. But before that we talked about the internet and the web. What's the difference? Anybody remembers? What's the difference between the internet and the web?
The internet's like the whole thing, where web is like World Wide Web.
Yeah, so the internet, the web is only what you look at in your web browser. Yeah. So you watching Netflix on your smart TV doesn't probably involve the web, but it involves the internet, the background infrastructure. And the big new idea here was packet switching. What was the good idea here with packet switching? Anybody remembers?
It split the message up into different packages.
Yeah. You should have all received emails with me with account credentials for our web server. And our web server actually happens to be in California. And like you said, we split up the message now. You got a 10 megabyte file to set. It will be split in lots of tiny packets. Each of them we write down who's the sender, who's the receiver. They'll travel over the internet. Before that, before packet switching, communication would have been connection oriented. Example would have been a telephone. So you want to call somebody, you dial their number and you create a connection. So I want to call somebody in some other city. Basically the copper wire in the past underground will be reserved for the communication between me and the other person. The copper wire can't be used for anything else while I use the copper wire to make a phone call. Now think about the fact that our web server is in California. So Europe has hundreds of millions of people, USA has hundreds of millions of people. Imagine we need to use a whole copper wire for each of those bits of communication. We need hundreds of millions of copper wires buried under the Atlantic. Of course you could combine them somehow, but packet switching is much more clever, because while we don't exchange information between two different sites, the copper wire can be used by others. So while I don't send bits of information to someone else, other people can use the same copper wire. I assume most of us have broadband at home. And I assume in the house there's more than one person. So you can all use the internet at the same time. One of you at home, imagine there's 3 people at home. One can browse the web, one can watch a movie that's being streamed, and one can play, I don't know, an online game, something like that. You can all use the same physical connection at the same time, because all the data you exchange is split into small packets, and they just travel one after the other. Of course, we need to communicate in a different way. So you send a 10 megabyte file of your cat playing piano or whatever it might be. It could be split in hundreds and hundreds of different packets. So each of them we need to label. Where is it from? Where is it going to? This is packet 1 out of, I'm making it up, 1 out of 129. Because they might not arrive in the correct order. But this was the big new idea, packet switching, and the internet is based on that. And yeah, 60s, we had the first universities connected. 70s, the whole thing went public. 40 locations were linked, email was introduced. TCP/IP was introduced in the 80s. We still use that protocol today. And 84, that's where we stopped last time, the domain name servers were introduced. Do you have a yeah. I'll show you some slides later. And then, late 80s, the World Wide Web concept came up, but it was the 90s before we had the first websites that went live. And let's have a look. Domain name servers, I mentioned them before. So do you remember how internet address looks like? At the moment, we are having this move from IP version 4, and we are moving to IP version 6. And even though your computer will probably, I wrote it in the top right corner. So even though your computer will probably understand IP version 6, your internet service provider might not understand it. So actually that we are still dealing a lot in IP version 4, even though that change has been happening for more than 20 years. So typical IP version 4 address consists of 4 numbers, each of them between 0 and 255. So can I have a volunteer who gives me a number between 0 and 255?
192.
192? Yeah, that's a special one. you know a bit about Ethernet and stuff.
A little bit.
A little bit, yeah. So that's a special one.
I don't know why.
The one he wanted to give us is one basically all the routers, all the switches, all the hubs in the world, they basically know this is a sort of internal address, and we don't let it spill over into the internet. If you've got equipment with that kind of number internally and you want to, I don't know, set it up as a web server, you need something in between that can translate between the outside world IP address and the internal IP address. But the one, I think I know where you were going with, and that would have been an internal IP address. So any random number between 0 and 255?
$120.
120? Good, 120, and another one? You are our random number generator now.
Between what, the same?
Anything between 0 and 255.
200.
200, good. Another
again.
Yeah.
17.
17, yeah. Last one.
167.
167, yeah. Okay, so that might be the IP address of a server on the internet, or it might not be, who knows. Who knows, maybe this is Google's IP address, maybe this is uCloud's IP address. So what happens? We got our browser, and our browser will have some sort of internal IP address, and it could be this one. And the web server, we could play the same game again and come up with another address. The web server will have another number. Let's just make one up. I'll just add one every time because I'm lazy and don't want to think of a new one. Imagine, so this is ours, and this is the server IP address. Just making it up. There's no link between them. That's how the packets I was talking about, how they are being addressed. It will say this is coming from 120, blah blah blah. It's going to 121, blah blah blah. So who received an email from me this morning? With your. So I set up a web server for you on our account, and it goes without saying, don't put your MP3 collection up there or other stuff that shouldn't be there. So it's usually your username, .wimserver.com. So anybody wants to volunteer? Hi. Everybody wants to volunteer their address, their username? who will volunteer their Uclan username.
I will.
You will? Thank you. Okay, let's go there. Come on. So tell me B.
BD.
Nah, why does my keyboard not work? BD.
FAW. CE. TT.
Yeah. Okay, yeah. So my machine has never before been to this address. So I didn't know what the IP address is, but yet I found it. So what just happened? Basically, why does my keyboard not work? They gave us all this new hardware, but it doesn't always work. Come on. Here we are. Yeah. So, when you visit a website you've already been to, your browser actually, creates a list and remembers all those IP addresses. So all those lines, they're supposed to be entries in my imaginary list that says, this address is this kind of IP. This web address is this kind of IP address. So there'll be lots of entries. Those lines are supposed to represent it. Now I went to your website. I've never been there before. So what happened? I couldn't find it in that list. But when I connected to the internet, I actually got the address of a DNS server. So there's another server here, DNS. And what happened was that I basically asked the DNS server, what's the IP address of, was it bdfawcett.binserver2.com? And the DNS server will look it up and will send the address to me. All the DNS servers, they are organized in a hierarchy, so in case the DNS server doesn't know, it will just ask the next DNS server in the hierarchy. And at some stage, they'll hopefully find out what the IP address is for that domain. And the moment my browser knows that, it can then send the request to the server, and it basically says, give me that page that's there. Now usually we type everything in lowercase. Theoretically you could configure the server so that folders, files and so on, that uppercase, lowercase plays a role. But usually we don't do that. On our server, if you use upper lowercase, that does play a role. So my suggestion is keep everything lowercase, because your visitors will not be used to entering a folder, a file name in uppercase. Most servers in the world are configured so that if you don't specify the file you want, just close the window because of all the construction work outside. Okay. Most servers are configured, if you don't specify the file you want, they'll send you a file called index. Yeah. So later we will work on our web server. You can create a folder, and let's say you put 10 files in that folder. Yeah. If we go to that address, our server is configured to show the contents of the folder. You create a folder, you put 10 files in, I'll see those 10 files as a list. But usually, we want some sort of landing page, some sort of page that our visitor first sees when they go to a specific folder. And we usually call that page index, because most servers are configured that if you didn't say which file you want, they'll send us the file called index. Yeah. And we can then link from that file to all the other files. Yeah, links were one of the big things of the web. I mean, hyperlinks, they were called originally. So the idea was you can quickly, easily switch from one page to another page. Links made that possible. Okay. Any questions so far? And we all know what a link is. We all have a rough idea how the web works, so I don't think I need to go into too much detail here. So the web has been around for 20 years. But yeah, there was a lot of development in the 90s, and we had a funny situation where different browsers were kind of incompatible to each other. When Microsoft wanted to be part of the browser game and they introduced Internet Explorer, they thought, oh, we'll do things a bit differently. And yeah, we want to dominate the browser market. And the way you had to, let's call it program, the way you had to program the web page, the way you had to put HTML text in, was slightly different to different browsers. So we had this kind of messy situation that people who made websites had to spend a lot of effort and basically create two different versions so that the same web page looked the same or very similar in two different browsers. It started very simple. It was just some text. You could, the web started very simple. You could put a picture in a corner. You could decide on what font you want. You can put a table here. But very soon people wanted their web page to look nice, and they wanted their web page to look like a locally installed software. So people started drawing borders around things, and the borders were supposed to have little shadows and so on. And we just had this messy situation where you had to program it in different ways for different web browsers. That got better over time, and these days most web browsers use the same kind of core engine to render a web page. But it was quite messy for a while, and then there wasn't much development until finally in 2014 HTML5 was released. And the web had changed quite a bit, over time. In the 90s, in the early noughties, we had Adobe Flash Player, quite popular. Who has heard of Adobe Flash Player? Yeah. It was quite popular. But the way it was programmed and the way people created animations and little videos and whatever in Adobe Flash Player wasn't very efficient. That meant if you were running it on a mobile device, it would use up more of the CPU, which would mean the battery would deplete much faster. I'm not 100% sure when it was, but I would think maybe, I don't know, 2009 or something like that, but I'm guessing now. By that time, Google, who's behind Android, and Apple, who's behind iOS, they decided we don't want that kind of stuff on our mobile phones. It's there's so many poorly programmed Flash things out there, Flash elements that are part of web pages, and they stopped supporting it on their mobile phone systems. And Adobe even, isn't that keen on it anymore. They're getting rid of it. It's still available for PCs, but that's even being phased out. And what was it used for? Usually people just used it to show animations or to show videos, things like that. But because we now had 20 years experience with the web, when HTML5 was developed, we put all of that into account. And HTML5, for example, has something built in to play videos, to create animations. I mean, you can fairly easily program a game in HTML5. I mean, I'm talking about some sort of 2D game, not some sort of Call of Duty-like thing or Grand Theft Auto or whatever. But 2D animations, moving things, it's all pretty easy, and it's all standardized, which is quite nice. Which also means that if you create something, you can be sure it will work on people's laptops, desktops, different operating systems. It will work on their tablets, on their mobile phones. But what stayed the same is that HTML is built on so-called tags. And here you can see a tag. Yeah. So we got tags. And here's how a tag looks like. I like to call them pointy brackets, or you could call them angles, diamond brackets, chevrons, whatever you want. And very often you got a start tag and an end tag, or you can also call it an opening and a closing tag. Here's an example. Now you're not supposed to use this one anymore. You know, B stands for bold. Why did that B disappear? So here we are. You're not supposed to use things like bold anymore. You see, the problem is that you are describing how it should look like, but you shouldn't really mix content and form too much. So instead you should basically, these days you're supposed to say, I want to emphasize this word, and it's then up to another part of the web page to decide how an emphasized word is supposed to look like. Yeah, so you're not directly supposed to say this should be bold, because when you make it bold, in the end you want to emphasize it. Yeah. But people still use it, so that's perfectly fine. So in this example, which one is the start tag? Have a guess? Haha. A or B? Which one is the start tag? A, yeah, and B is the end tag, and everything between A and B is gonna be bold in this case. Yeah, or you know, I think is for italics, I guess. Yeah, there are lots of those. So very often tags come in pairs, but not necessarily. There are also some tags that are just there by themselves. And here's a very basic HTML file. So here is a start tag or an opening tag. Where's the fitting end tag? Difficult. Should I label the lines? 1, 2, 3, 4, 5, 6, 7, 8. Which line has the closing tag for the start tag in line 1? Have a guess. 3?
I just seen the slash
Okay.
title.
Yeah. So okay. The closing tag always looks like the opening tag with a forward slash. Yeah. So the answer is 8. Yay. So here we are basically saying we are opening the HTML document, and look, this is the same with a forward slash. So here we are closing it. And here head. That's the header of the document. Line 2, we are opening the header. Where do we close it?
4.
Line 4, yeah. And we could put other things in. I put title in. We could put in, for example, who's the author. We could put in a description of the web page. And then in a search engine, the search engine might put the description of the web page under the title. Yeah. So there are lots of things we could put in there. And the main body starts actually here. Yeah. So everything between the body start tag and the body end tag will be our main web page. So all the rest here is just kind of admin stuff. And there'll be specific tags, you know, to include an image. There's one called image source, and then you know, you basically say what image you want. You could have a list. You could have an ordered list or an unordered list. There are lots of tags that you can use. And we'll look up a little bit at HTML. But in the end, this is just to get to understand how web pages work. And sometimes they can be quite quirky. And to understand the quirkiness, I jump a few slides back. Yeah, a lot of the quirkiness is based on the fact that actually we are sitting here, but the web server is somewhere on the other side of the internet. In our case, our web server is somewhere in California. Yeah. So the code is actually running far, far away. The code is running over here. And that means, for example, things don't necessarily automatically refresh. Things might have changed on the web server, but I still see the old version. You go to, is there any big event going on at the moment? Is the Formula 1? I think there was in the news yesterday. Any sports fans here? I'm not.
Champions League, maybe.
Champions League? That's football, isn't it? So they've started the new season?
The tournament was like the middle of the tournament.
Okay, so, and tell me a good team.
Real Madrid.
Real Madrid. So you go to the Real Madrid Wikipedia page. Yeah, I don't know. And now suddenly they win the Champions League. Yeah. If you don't press refresh, it's still gonna say, they had, I don't know, so many titles. Yeah. Only when you refresh, because the web page was created here on the server, and then it was sent to you, and it's just in your machine. Yeah, it's not a locally installed software. So there are a lot of those kind of quirks that are happening because of the way the internet and the web works. So when we install a content management system, all those quirks, like things don't refresh automatically. I mean, we could program that it does that, but by default it doesn't. So there are lots of different things that happen the way they happen because of the way the web works. So I think understanding HTML to some extent and seeing what's going on in the background will help us understand why our content management system behaves the way it does. In the end, once it's all up and running, you just manage the system from some sort of admin interface. And the system just consists of lines of PHP code. And those lines of PHP code, they will basically just create HTML code that will be sent to the people who visit our website. So you manage the CMS. So that's you. You manage the CMS. The CMS runs on PHP. PHP creates HTML code, and the visitors to your website, they then get the HTML code. Yeah. There's also a database built in here. Okay. So we'll slowly get familiar with HTML. We'll get a little bit familiar with PHP, not too much. Then we'll talk about things like, I don't know, image formats and stuff like that. That's probably more important because that's something you'll actively use. And then we can start getting our content management system up and running. Yeah, so if you use your account on the server, you have to follow those acceptable use policy description you find on that web page. Yeah. So obvious things, I think it's pretty straightforward. Don't upload your music collection or whatever. I think you know what you're not supposed to upload, but if you're in doubt, check those files and they'll give you some sort of better idea. The best thing might be probably, if you've got a laptop anyway, if you bring it along, you might as well work on your laptop in the workshops. But in the end, we don't need specialist software installed on your machine, because the whole thing will run from the web once it's up and running. So once the whole system is up and running, all we need to do is we need to log on to your CMS, and you can do that from any internet connected computer with a web browser. But for today we'll try to write some HTML, and we then need to get it to the web server. Let's hope the keyboard works. Why doesn't? Oh yeah, yay! Paint. Let's start Paint. Yeah. So let's use blue for a change. Eh? Who's heard of HTTP before? Yeah. So HTTP, where have you seen it?
When you type on a website. it comes up.
Yeah, and there's also HTTPS. S then just means the whole thing is encrypted. So there's a server somewhere on the internet, and somehow, you know, this is supposed to be your machine. It's your laptop. So HTTP, you visit a website. Yeah, the website is being sent to you. But now you got an area on the web server. Your own machine is not a web server. Yeah, you close the lid. This is supposed to be a picture of the same machine with the lid closed. Nothing works. By default, your machine is not a web server, which means that if you create a HTML file, it's nice on your hard disk, but people all over the world can't access it. Where does the HTML file you'll create, we create a HTML file today, where does it have to go so that people can see that web page you made all over the world?
The server.
To the server, yeah. And we do that using something called FTP. Yeah, the P in both cases stands for protocol. So FTP is a protocol to send files to a server, or you can also use it to download files. It's just a protocol to move files around. But we'll use it to send files to the server, and we'll use a software called FileZilla. There are lots of different FTP clients, but the one we are going to use is called FileZilla. It's free, and it's available for lots of different operating systems. So if you've got Windows, if you've got Apple, you can get FileZilla. It's free. If you download it, download the client version, because there's a server version. You don't want the server version, you want the client version. So you'll create a HTML file, and an HTML file is just a text file with HTML tags in it, and the file extension .html. There's no magic to it. Yeah, so Notepad, TextPad, whatever text editor you have, they can all write HTML, because it's just a text file with the file extension .html. You write that HTML file, and if you double click on it in Windows Explorer or on an Apple in Finder, it will just fire up your browser and you can look at it on your local machine. But in the end, we want stuff on the server. So you create today, first step, you create an HTML file. A second step, you use FileZilla, an FTP program, and you send it to the server. And I gave you username and password. And once it's on the server, basically the whole world can see your file. So if you call the file, I don't know, test.html, HTML. Can I delete with this end? No. New page. Don't save. Okay. So let's say we call the file test.html. And what was your account? BD Fawcett? Yeah. BD Fawcett dot bimserver2.com. Let's say you put it in a folder called BT2201, and then you upload the file test there. Then if people enter bdfawcett.bimserver2.com slash BT2201 slash test HTML, they'll see that file. If you spell BT2201 in uppercase, then people need to type it in uppercase. Otherwise, for the computer, uppercase and lowercase is different. So keep everything lowercase, don't put any spaces in. Because when people are on the web, they are not used to typing uppercase. And you tend to type everything in lowercase. So all the files you create for the server, all the folders you create for the server, keep them lowercase. This is also an exercise of getting files from our machine with FTP to the server. Because once we install the CMS, there will be thousands of files we all have to shift from our local machine to the server. Any questions so far? Okay. I've got some handouts for you, but I got to pick them up from the printer. So if we go to the computer room, I'll give you the handouts, or if you don't want to wait, you can look on Blackboard already. So today we'll create an HTML file and we'll send it to the web server, and then hopefully, if everything works, you can go to your address on the web server and you'll see your file.